Work, energy, and power. We throw these words around every day, right? We talk about working out, having zero energy, or a powerful engine. But what if I told you that in the world of physics, these words mean something way more specific and honestly a lot more fascinating? Let's dive in and find out what they really mean. Okay, so let's start with work. In everyday life, work just means putting in effort, going to your job, studying for a test, hitting the gym. But in physics, the definition is so incredibly strict that it's probably going to change how you think about effort itself. I mean, just look at this weightlifter. Muscles are straining, sweat's probably dripping, holding hundreds of pounds over his head. That sure looks like hard work, doesn't it? But here's the thing. In physics, is any work actually being done at the exact moment he's just holding it still? The answer might surprise you. Or how about this? Imagine you push against a solid brick wall with every ounce of your strength. You push and push for a whole hour. You are completely exhausted, but that wall hasn't moved a single inch. According to physics, despite all that effort, you've done absolutely zero work on that wall. So what gives? How is that even possible? Well, the reason is actually pretty simple. For work to happen in physics, two conditions have to be met. One, a force is applied, and two, that force makes the object move some distance. Physicists call this displacement. If there's no movement, there's no work. End of story. And the basic formula for this makes perfect sense. Work, which we call W, equals the force applied, F, multiplied by the displacement, or S. So if that displacement, S, is zero, like with our unmoving wall, then it doesn't matter how much force you use. Anything times zero is zero. No work done. But this is where it gets even cooler. It's not just about if an object moves, but the direction of that movement is absolutely critical. The angle between the force you're applying and the direction the object actually travels, well, that's everything. So here's the complete formula. Work equals force times displacement times this thing called the cosine of theta. Now, don't worry about the math here. Just think of cosine of theta as a special factor, a number that tells you how much of your push or pull is actually going in the same direction as the object's movement. This really breaks down into three key scenarios. First, if you push a box and it moves in the exact same direction you're pushing, that's a 0-degree angle. You're doing positive work. Now, second, think about carrying a heavy suitcase. You're lifting it up with force, but you're walking forward. That's a 90-degree angle. In this case, the work you're doing against gravity is zero. And finally, if a force opposes the motion, like friction slowing something down, that's a 180-degree angle. We call that negative work because it's taking energy out of the system. And this right here perfectly illustrates that 90-degree rule. See, on the left, when you lift the box off the ground, your force is going up and the box is moving up. That's positive work against gravity. But on the right, when the person is just walking forward, gravity is still pulling the luggage down. That's a 90-degree angle to the forward motion. So weirdly enough, no work is being done against the force of gravity as he walks. So, okay, we've kind of got a handle on what work is, but work doesn't just happen out of nowhere. It's got two really close relatives, power and energy. You can think of it like this. Work is the action itself. Power is how fast you do that action, and energy, well, energy is the fuel that lets you do the action in the first place. Power is all about speed. It's the rate at which you do work. Think about climbing a flight of stairs. Whether you walk up casually or you sprint up, you're doing the exact same amount of work against gravity to get your body to the top. But sprinting takes a lot more power because you're doing all that work in much less time. So what fuels all of this? The answer is energy. Energy is the big one, the most fundamental concept of the three. It's simply the capacity to do work. You could even think of it as the currency of the universe. If you don't have energy, no work can be done, and therefore no power can be generated. This lays it out perfectly. Energy is your potential. It's like money in the bank. Work is the actual action of spending that money, and power is just the rate you're spending it at, a little at a time or all at once. It all starts with energy. Without it, the other two can't happen. So where does this energy actually come from? Well, in mechanics, it usually shows up in one of two main forms, potential and kinetic. You can think of them as two sides of the same coin. One is energy that's stored up, and the other is energy in motion. So you have potential energy, that's stored energy. It's energy that's just waiting to be released, like the energy in a stretched out rubber band, or in a ball you're holding at the top of a hill. Kinetic energy, on the other hand, is the energy of motion. It's energy in action. A car speeding down the highway has a ton of kinetic energy. And the pendulum is the absolute perfect example of these two forms of energy doing a beautiful dance together. At the very highest point of its swing, the ball stops for just a split second. At that moment, all its energy is potential. Then as it swings down, that potential energy converts into kinetic energy, and it's moving fastest with maximum kinetic energy at the very bottom. And as it swings back up the other side, that kinetic energy transforms right back into potential. It's just a beautiful, continuous cycle. Now, this constant transformation, this back and forth, isn't just some neat trick a pendulum does. It actually points to one of the most fundamental and honestly profound laws in all of science. And here it is, the law of conservation of energy. What this means is that the total amount of energy in a closed system, heck, in the entire universe, is constant. It's always the same. It never, ever disappears. It just changes form. And what a shapeshifter it is. Think about it. The chemical energy inside a battery becomes electrical energy, which flows through a wire and becomes the light and heat energy coming from a light bulb. The mechanical energy of a spinning turbine becomes electrical energy for our homes. All the energy that has ever existed is still here, right now, just wearing a different costume. So when you really stop and think about it, here's the ultimate takeaway. Every action, every movement, even every thought in your head is a transfer of energy. It's never made from scratch, and it never truly vanishes. It's just passed along. And that leaves us with a pretty profound question. Since all the energy in the universe is just changing hands, what will you do with yours?